electronic project number 2, design a DC power supply with back-to-back converter, or another name is switching regulator. What's switching regulator? It's actually create kind of DC from the AC, and you switch it around to adjust the output voltage. Why you do that? It can be smaller and less wasting power. A little noisy on the output, has still some noise, but the benefit is overwhelming. So it's used for the small USB power supply like this. You see this type, small and doesn't heat up all over, and also like a computer power supply or any equipment use that. Okay, so AC DC power supply, there are two types. The first video explained voltage regulator type, and here we talk about back-to-back converter, and it has a big advantage: less wasting power, and it can be smaller. So before getting into detail, let me show you some hand-on fact you can easily verify. Here's this is a signal generator, okay, and you see, let's see, signal is like rectangle shape, duty cycle is 50-50. Okay, you can change duty cycle on this. Now you see the plus voltage increased. Duty cycle is 75. What duty cycle you can decrease. So the spike get very narrow. So that's what we can do with this signal generator. And we have a project to make your own signal generator later in the video, so you should look at. This is a very low cost, like $5 or less signal generator that do pretty good job. Now, very simple setup. We measure the output voltage. So it's a 5 volt. The average shows 2.463, right? It's slightly less than 2.5 because this is not exactly 5 volt. It's the TTL output. It's slightly less than 5. So the average become half, about half of that. But if you change it, duty cycle, increase the duty cycle, you see the average increase, right? Voltage goes up. If you decrease the duty cycle, see the average output voltage decrease. Okay, so basically it's possible to have some kind of DC power supply like that, and using capacitor to average out. Okay, so if you average out, then you get the desired voltage, output voltage. Why you do this way? Well, time slicing like this, the output, and adjust the time slice depend on the output voltage you desire, is much more power efficient than the, remember that the first video shows there is a voltage drop, input voltage and output voltage, and that difference is going to be all wasted power. So the voltage regulator type need a big heat sink. It's generated heat. All the wasted power become heat. But back-to-back converter, you don't have a heat generated. Okay, so let me turn off this. Okay, so here what we have is, let me turn off this setup. Basically the wall, look at the first video, 120 volt, this is the RMS voltage, step down transformer, and use a diode, and use a simple filter. It doesn't have to be very clean here. It can be like that. And switching regulator, the back-to-back converter is going to time slice and eliminate this part. So basically waveform become like this, right? So the output voltage, if you want the 5 volt, the duty cycle 50 here, 50% to be 5 volt. And if load increase and voltage start dropping, then time slice change to say 60%, pump up more charge to the capacitor. So you can guess there is a output capacitor here inside the circuit, and pump up more charge to maintain the 5 volt. So you can tell switching regulator or back-to-back converter, what they are doing is monitor the output volt, feedback to the voltage comparator, and depend on voltage comparator, adjust the time slice. Okay, so it's all done by a single IC chip. It's very convenient. Then you don't have to worry about. So here it's explained time slicing. Okay, duty cycle control. This is the IC chip, V in, and this is a switching transistor. It's on and off, and this is output voltage. Go back and monitor, and if output voltage is low, turn on this, so it's turned on early and the duty cycle increase, and there is a short circuit protection. If it's overloaded, it shut off this. There is a reference voltage. If it's 5 volt, you want the 5 volts as output, it's compared with 5 volt. And if load get less, then you don't need that much current. The voltage tend to increase, the millivolt increase, then it's shut off early, duty cycle decrease. Okay, so this output is filtered into 5 volt low pass filter. So that's the basic principle of back-to-back converter. Now this is a good example. There's no wasting power at all except for the power operating the circuit. And see, this is a single chip, the switching IC chip, and this 110 volt coming in, and diode, and the capacitor, simple filter. Before going that, it's voltages go to the step down transformer and going through diode, this, and it's provide the kind of rippled DC output, and that rippled DC output goes to this switching IC chip and go through the simple filter capacitor output. Then you get the steady 5 volt, and in the process power loss is very minimal. Okay, so that's a back-to-back DC power supply, and it's very popular. All the laptop, PC, and even this type of a small power supply, all use this back-to-back because you don't need a heat sink. So you can guess, and historically the power DC voltage regulator type was used everywhere, but power loss is too much, and later this kind of IC chip is created, switching regulation, and that became the mainstream. But switching regulation, you're monitoring output, so there will be some ripple, like millivolt, 10 millivolt kind of ripple on the output. That's the disadvantage. So very sensitive analog circuit, they don't use this back-to-back converter. They still use a voltage regulator, which is very stable, down to millivolt. Okay, that's all for this second video. You can move on to the third video if you're interested.